Today's episode is sponsored by SimWell. Digitalize your operations with simulation. Visit them at simwell.io.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. I'm your host, Amy Bryson, contributing lead editor of Smart Manufacturing magazine. Today we'll be talking about how simulation-based digital twin technology can digitalize operations. I know that's a topic that is of great interest to our listeners. And my guest today is Jon Santavy, partner and CRO at SimWell Consulting and Technologies. For those of you who don't know, SimWell helps business leaders gain confidence in making big decisions through simulation, optimization, and digital twin technology. Jon has worked in the simulation space since 2007, so he's seen a lot. And he has a lot of experiences and insights to share with us today about how manufacturers are using the latest technologies to achieve smart manufacturing success. Well, I want to thank you for joining us, Jon, and welcome to the show.
Yeah, thank you, Amy. I appreciate you having me.
You're welcome. And before we jump in, can you give our audience just a bit more background about yourself and the work you and your team are doing over at SimWell?
Yeah, absolutely. I've been working in simulation for about 15 years or so, in a lot of different ways. And so, simulation is a really fascinating industry where it's been around for 40 plus years, a very proven technology that has been expanding and growing as organizations get more access to data, and they're trying to figure out what can we do with it and how do we make our operations more efficient and our teams more efficient, and how do we improve on it. So it's seen a lot of change in this industry over the last 10 to 15 years. I've started working with a big organization that was doing simulation for about 6 or 7 years before moving to do this through SimWell, through our own company. And at SimWell, we are, I believe, the largest company in the world dedicated to doing simulation, optimization, and digital twin. We've grown from about 5 to 80 people over the last 5 years or so because of the adoption, because so many folks are adopting this technology and understanding the value of this technology and applying it across their sites, across their enterprise, from manufacturing to supply chain and warehousing, logistics, all over their operation. So we've got a team of about 80 folks, primarily in North America, but we've got teams all over the world in order to be able to support not just simulation models, but digital twins that need to be have more 24/7 type support. So we're building our organization to execute on the traditional types of simulation projects and turn those simulation models into the simulation-based digital twin and support those at an enterprise level at scale.
So let's talk a little bit about that and, kind of the tactical elements of simulation and how it is related to digital twins. If you can kind of break that down, because, at Smart Manufacturing, we talk a lot about automation and different tools and technologies. But just from a practical level, what does it mean for a manufacturer who is looking to adopt simulation and digital twin technology?
Simulation is a tool that's used to create a virtual model or a process of a system, and it allows us to analyze and experiment on that system without impacting the real world operation. So it's in a completely risk-free environment where we can introduce new processes, new resources, new automation equipment, or changes to how labor works within the manufacturing sites. And it's widely used in manufacturing because we can test and compare scenarios, optimize processes, material handling flow, and then predict the outcomes after a change. Now, a digital twin, on the other hand, is when we take this simulation technology that's been proven for 40 plus years and connect it to real-time data. So while simulation can be considered a component of this digital twin, the digital twin goes a step further by allowing for ongoing optimization and proactive issue resolution. So the digital twin can be applied in the manufacturing plant, a warehouse, or a distribution center, and even a supply chain. And the digital twin provides decision support and even decision automation where it's applied, which could be production scheduling, resource planning, S&OP planning, route optimization, and many other areas around the operation.
Yeah, you talked about some of the key value that simulation brings to manufacturing operations. I'm wondering what types of problems are most effectively solved by implementing simulation technologies. It sounds like you work with a lot of companies to help identify and solve problems. So what are you hearing and what are you seeing?
Yeah, so there's a couple key benefits that come out of these manufacturing operations. Firstly, it allows for testing and validating the process changes in this risk-free environment, which helps to avoid costly mistakes. It also aids in optimizing production processes by identifying bottlenecks and inefficiencies, which leads to improved throughput and reduced operational cost. One of the key benefits of simulation is addressing issues in an operation at the systems level. We had a customer that made a $50 million investment in automation equipment that didn't meet the expectations because the process wasn't addressed at a systems level. So we were able to simulate that process and test changes into the process, the equipment, the speeds, and again, a completely risk-free environment, and then compare those scenarios to help the company make use of that major investment. So folks come to us, really at 2 points. Either they're making a change and they want to make sure they get it right the first time, or they've already made a change that did not meet the business needs, and they're looking for a way to fix it. So simulation can enhance the decision-making by providing data-driven insights, enabling more accurate forecasting and planning in the business. And almost all industries are struggling with things like hiring and the loss of institutional knowledge as folks leave and retire, and that's especially true with manufacturing. So with a simulation and digital twin project, we're able to capture the institutional knowledge before it's lost and make people more efficient and ideally support or automate decisions within the operation. So overall, it leads to higher efficiency, better resource utilization, and more flexibility in responding to change. And it's particularly effective in addressing complex manufacturing problems like production scheduling, capacity planning, and process optimization. It can help with identifying and resolving bottlenecks, optimizing the layout and the flow of those production lines, and evaluating the impact of new investments or process changes. It's really invaluable in scenarios where there's multiple variables and uncertainty, such as supply chain disruptions or demand fluctuations, or the different types of labor that are like different variability in how labor or machines handle a certain process, or how much time it takes for a process to complete. So by modeling these different scenarios, manufacturers can develop robust strategies to mitigate risks and enhance resilience within their operation.
Yeah, that's a big topic that we speak about often is, resiliency with so many different variables coming at manufacturers all the time, whether it's, supply chain disruptions or, pandemics or, there are myriad things that can happen. So being able to have consistency and resiliency is so key. I'm wondering what your customer base looks like. Is it mostly large organizations or small and mid? What does that look like?
Yeah, that's a great question, and especially I used that example of a customer that invested $50 million in automation. And while we do have those large enterprise customers, we also do a lot of work with let's say mid-size manufacturing companies as well. So anybody that's making big investments that are not simple to solve for, right? Because simulation is very valuable whenever you have a complex system with variability, resource constraints, and system interactions that are impacting it. So it makes it difficult for even an expert to understand how a change here is going to impact the system overall, or the throughput or efficiency of the process overall. So that's whenever simulation can be valuable. And although most small manufacturers, they can get by without investing in simulation, it really starts at that mid to large enterprise level.
Right. And you talked a little bit about this, but when is the right time, and how can manufacturing leaders know when the right time is to implement simulation in their process? What are some of those inflection points?
Certainly the right time to implement simulation really depends on a few different factors. I'd say leaders should consider implementing simulation when they face complex decisions or scenarios where they have to evaluate a large decision, where there's frequent process changes or significant investments in new technology or infrastructure. Another one, if there's a persistent issues with efficiency or quality or capacity, simulation can provide the insight needed to address those challenges. And it's also a good time to consider simulation if the organization is embarking on a digital transformation journey or aims to stay competitive in a very changing market. Because without simulation, how a lot of how companies have traditionally addressed problems is they make a change and then they hope that it meets their expectations or does what it's supposed to do. But that could take weeks or months or years before you are able to quantify if that change gave you the return that you expected, and it may be impossible to compare different scenarios. So with simulation, we could test shifts or days or weeks or months or years in a matter of seconds and compare the scenario A, B, and C very quickly, so that companies are able to, or leaders are able to make decisions that are backed by data and backed by a very thorough process, so they're more confident whenever they make that decision.
Great. And what are the typical steps involved in a simulation project? We talk a lot about people embarking on, smart manufacturing, digitalization, Industry 4.0. But what are the practical steps involved in taking a simulation project from start to finish? And what should businesses expect during this process? What are the need to knows about what's going to happen during this process?
Yeah, a typical simulation project involves a few key steps. It really starts with defining the objectives and the scope of the project. We have a saying that we always want to build the simplest model to solve the business problem. There's a lot of reasons for that, but it starts with making sure we define those objectives and the scope. And the objective of simulation is never to build a model; it's to solve a business problem. So we need to make sure that is well defined. We don't recommend that, hey, we have a manufacturing plant and now we want to build a simulation model. We want to start with, hey, we have to make this decision, or we have to make a series of decisions, and we want the simulation model to support that. So then we can build that model to tailored to what business questions are that are being asked, or the operational problems that we're trying to solve. So next, once the models, next we get into model development, verification, and validation to ensure it reflects the real world processes accurately. So that's a really important part. What the folks that are involved, the stakeholders, need to trust the model, and they need to trust what the model is telling them. So in all of our projects, we go through a very thorough process of verification and validation, where we compare the outputs of the model to the real world operation. And by doing that, we can help to build trust in what the model is, the model is accurate. And then the changes that we make in the model are also going to be accurate to support the decision that needs to be made. So once validated, we go through various scenarios, we test them to help analyze and identify the best solutions. Then the findings are implemented in the real world processes, and outcomes are monitored to ensure the desired improvements are achieved. So businesses should expect a very collaborative effort, involving cross-functional teams, clear understanding of the project goals, and a commitment to data accuracy and continuous improvement to make the best use of these tools. Something we hear in almost every project is that the value isn't just in the simulation model that we deliver, or the analysis that we deliver. It's going through the process of documenting the manufacturing process and documenting how the system actually works, because we're not just working with, let's say, one person that thinks the system works in a certain way. We're talking to people on the floor, to managers, to engineers, and we're getting an understanding of how the operation really operates. And then earlier I mentioned institutional knowledge and capturing that logic, and that's part of where that's coming from, even before we get into building and developing the models.
What is this is probably a silly question, but like a timeline, a typical quote unquote timeline for a project? What should people be expecting?
Yeah, in manufacturing, of course, you have. It depends. Are we starting with like a single line? Are we trying to model a site with a bunch of lines, or a lot of complexities and changeovers? And but I'd say on a typical project, we're looking at somewhere between 10 to 16 weeks. Of course, there's some that are more, some that are less, but is probably a pretty good estimate in manufacturing.
And it sounds like it's important for manufacturers to have a partner throughout this process. So, very consultative, be able to kind of hold their hand along the way. Is that your experience?
Yeah, the simulation isn't easy, right? It's not. It takes a lot of.
It's not a do-it-yourself.
Yeah, I mean, you could certainly try, but it is what we're really doing is we're taking a real-world process and we're building it in a virtual environment and in an accurate way that is scalable and flexible and fast to support the decisions that need to be made. So that's why we've been able to grow the way we have, is partnering with our customers and being as efficient as possible and building these models, not just to answer one question, but making them flexible and scalable to be able to support many of the questions as they continue to change and grow and build their business. And we're trying to extend the life cycle of their investment so they can be used ongoing. And that's, again, where we get from the traditional simulation model to the simulation-based digital twin.
Yeah, that makes a lot of sense. So looking forward, what are you seeing in terms of emerging trends or advancements in technology that manufacturing leaders should be aware of when it comes to simulation and manufacturing?
Yeah, so simulation and simulation-based digital twin is such an interesting industry because, again, this technology has been around for a long time. It's very proven, but now there's increasing integration of artificial intelligence and machine learning and optimization, which can enhance the predictive capabilities of simulation models. And even going from where it's a scenario planning tool to just a decision support or decision automation tool, where we can integrate these into business applications, into operating systems to help with how a business is working. So the adoption of cloud-based simulation platforms is also on the rise, offering more scalability and accessibility. So we have customers that have traditionally maybe done this with one site or two sites, and now we've built solutions that are scaled across 400 sites and interfaces where not just the engineers are using it, but folks on the floor, folks that are managing an operation are able to use this for those daily planning or scheduling problems. And then, the concept of the industrial metaverse is gaining a lot of traction, where simulations are part of a broader digital ecosystem that includes your, IoT, your augmented reality and digital twins. So kind of having a strategy around, simulation can start in two different ways. One is we have this business problem to solve. How do we, can simulation help support that? And then how do we take that model and integrate it into our operation to help with ongoing improvement, and staying informed about those trends and those changes can really help with leveraging simulation to its full potential and driving innovation in the operation. We often find it's one of the best kept secrets once, and when people find it and they realize the value that can come from an investment like that, they just keep investing and keep expanding it wherever they can in their enterprise.
Yeah. So if a company is considering, incorporating simulation into their manufacturing operations, what advice would you give them?
If it's the first time adopting simulation, the best advice is starting with defining the business problem or defining the objective of what you want to do and the scenarios that you want to test. And that can help help with making the process much more efficient, right? You can, there's an older gentleman that had done this for 30 or 40 years. It's since retired. One of my favorite folks I've worked with that always said, you can model something to the gnat's hind end, but you don't always need to, right? So understanding what the objective is and what the scenarios are can help with defining the level of detail that you need to go into the model, which, of course, if you can stay at a higher level of detail, you can build it faster and lower cost and be more efficient in your runs and support the business. So starting with what are my objectives and what are my scenarios, or what are the key metrics that I want to get or I want to compare these scenarios against, will help new folks, have conversations with companies like ours and figure out if simulation is a good fit for them. And
so tell us what's going on, at SimWell. You have anything coming down the pipeline Are you going to be at any events? Where can our listeners check you all out?
Yeah, absolutely. So check us out at www.simwell.io. There is a resource section that lists all the events that we're at. We just recently attended the Smart Manufacturing event here in Pittsburgh, and we have quite a few others. There are a ton of resources there on not just manufacturing, but supply chain, warehousing, distribution centers, and even example models that you can access and play with. And then if you're interested in whether this could be beneficial for you, there's a contact form, so you can reach out to us and we can help answer any questions.
Wonderful. Well, Jon, I want to thank you for taking time out of your day to speak with us today and share your valuable insights with our audience. And I'd like to thank our listeners for tuning in. Make sure you stay up to date about what's happening in advanced and smart manufacturing and hear more podcasts by visiting us at advancedmanufacturing.org.